So this is a short guide to typesetting mathematics for students in Mat 21-25. If you already know how to do this and you have your own preferred system, that's great. You don't have to follow along with any of this video. You can use your own system. For everybody else, though, I'm going to be starting from the beginning. In this video, I'm going to be referring to two documents, both of which are accessible in Brightspace, so I suggest it wouldn't be a terrible idea to open up Brightspace right now so you can follow along with the video. Okay, I'll assume that you paused and went and got them, and I'll carry on. So the basic idea is the following. Up until this point, I think probably you've handed in math assignments by handwriting using pen, and that's perfectly okay. But at some point, almost everybody starts writing up mathematics on a computer. It's certainly much easier to read, and it has other benefits as well when you get a little bit of practice. I'm going to be suggesting that people who haven't used it before use the system that I've sort of written up for this particular class. And there's a little getting started guide. And so the first thing you do is you go to this website called overleaf.com. If you look in the video up here, you can see that I'm at www.overleaf.com, and then I have /project/ and then a bunch of garbage because this is my own Overleaf account, and I have quite a few documents in here. When you go to overleaf.com, you're not going to see this. You're going to see a little website which lets you set up an account and create a new document. And so you can go and do that yourself. And again, I'd suggest pausing the video while you make your account and get yourself set up. Once you've done that and you've created a new document, you're going to see something that's very similar to the current video. There are going to be three panels. This panel on the left describes all of the files. You'll just see one, which will be called main.tex. main.tech, and here I have a bunch of pictures and references and so on, and they show up over here in sort of the other related files. And you can switch between them by just clicking on them as you go. The second panel, which is the main one, is this one over here, and this is the panel that you're going to be typing in. And this looks a little bit like gobbledygook at the moment, I'm sure, but we'll get a little bit of practice. And then the final panel, this third one, is the panel which is the output of the LaTeX. So this is what it will look like once you're done. And you can hit this button up here called the compile button. And what the compile button will do is it will save all of this code that you've written up here, and it will create a new version of the PDF file over here. This is probably a little bit hard to see, but I've downloaded the version before, and this is what it looks like once you've downloaded your own copy. So this is the part of the file that you actually send to another person who you want to read your mathematics, or when you're submitting your homework, this is the file that you send to me. All right, so that's what LaTeX is, or at least that's what Overleaf is. And then there's a question, so what do you do? Well, if you look on Brightspace, you'll find that there's a file called template.tex, and it's this stuff here. So I have the entire content of the file here. So you can just go and open that up and hit Control-Alt, Control-C to copy that into your own LaTeX document. And when you do that, you'll get this thing here. And if you hit Recompile, you'll get this very short document over here. And I suggest that if you're doing homework and you've never used LaTeX before, that every time you start a new homework assignment, you copy-paste the template.tech file into a new Overleaf document, and you'll see that it has all of this stuff here for you to start entering in your own values and to start answering some questions. All right, so what's going on in the template? What do we see when we open this up, and what are the things that you edit? So there's this stuff at the beginning, document, class, article, and so on, which we're just not going to touch. The next part, this is what you do touch, is the title. So it says /title. So this / thing is LaTeX telling you, hey, I have a command here. So there's a special thing called the title. And then there are these curly braces, and curly braces are what LaTeX uses to tell you that there's an argument to its special function. And then you can have the text inside, which can be whatever you feel like. And as you can guess, if you don't touch the special stuff, this /title in blue, and you don't touch the curly braces, but you can put whatever you feel like in here. So here it says template Mat 21-25 homework solutions, but I can also write, for example, Aaron Smith's first assignment. And when I do that and I hit recompile, it pops up here. Okay, and I'm going to go back to the old version now. The next field is very similar, /author, and so you can put your own name there, and as you can guess, I write my own name, and I hit recompile, it's going to pop up right here. Okay, then there's a whole bunch of stuff which we're not going to touch. All of this use package stuff, this is instructions for LaTeX, and we're just going to ignore all of it. until we get down to here, where it very helpfully says begin document and end document. Begin document and end document are telling LaTeX, hey, here's where the main file is. And everything between there is stuff that you get to type in. So the first thing it says is /section, so that's just like /title. You get to type whatever you feel like, and it shows up in nice bold font. Then you get to write just whatever math you feel like in here, and it shows up in normal font down here. Another /section for some more bold font, and then some more normal text for some more stuff over here at the bottom. So it's fairly simple once you get started. And you can see over here, there's not that much text over here on the right-hand side of the template, and I've just shown you where all of it's coming from. Most of it is this little bit here. A little bit of it is this little bit at the beginning, and everything else you just sort of ignore, and you'll get used to just skimming right past it when you're typing up your homework assignments. So that's the basics of LaTeX, or at least that's the basics of a LaTeX file. What are we actually doing, and why are we bothering to do any of this? Well, the short version is that LaTeX has some really, really nice ways of typing up mathematics. So I'm going to skim over some of this for now. If you open up the document, you'll see I talk a little bit about things like special characters and special commands and so on. So for example, here I have a numbered list, and I say how you can do that. But I'm going to skip over that. That's sort of not the main part, and you can look for yourself. The main reason for doing LaTeX is this thing called math mode, which lets you typeset mathematics really nicely. So I'm going to jump to that part of the document so you can see how the stuff that I'm writing corresponds to the stuff that you see in this panel here on the right. Okay. Here we go. So I have this section, like I said, /section math mode gives me this nice bold-faced title. And then here you can see that every time I want to do some mathematical expressions, I write a $sign. That might be hard to see in the video, but there's a $sign right there at the beginning and the $sign right at the end. And that tells me, hey, I'm entering math mode right now. LaTeX, you need to parse this in a special way. Okay, so every time you want to do anything that's mathematical, like an x squared or an integral or whatever, you put a $sign at the beginning and a $sign at the end. And then after that, you sort of look through all of this, and what you'll see is that there are these little slash and then strings of characters, which correspond to special symbols. So here I've written a /int or /int, and over here I have the integral symbol. I then have this underscore and a 1 in braces, and I have a 1 at the bottom of the integral, and I have a superscript here thing, and a 3, and I have a 3 at the top of the integral. Okay, so what's going on here? Well, basically, every time that you want to write a special character into LaTeX, there's going to be some special string, and it almost always looks like slash and then a few characters. Okay, so slash and then a few characters, and that's going to correspond to that symbol. So every time you want to write the symbol, you just write those characters together inside of math mode. Okay, and that's going to get you to the vast majority of LaTeX. Okay, or at least the vast majority of simple symbols. So that gets you the integral, and it gets you the sign, and so on. Now, every once in a while, or in fact fairly often, just having special symbols isn't quite enough because you need the symbols to be in a special place. That's one of the reasons it's so annoying to typeset mathematics. So for example, in the integral, it'd be a little bit easier to see here, right? We all know the integral has sort of a number or a thing at the bottom and a number at the top. And you don't want the 1 and the 3 at the bottom and the top of the integral to just be sitting there next to the integral symbol. You want them to be sitting in the right place. And the way that LaTeX deals with this is it uses arguments, which are inside of the curly braces. So in this case, we put the integral, and then we put underscore curly braces to put the number at the bottom of the integral, and then this up pointing arrow thing, and then 3 inside of a curly braces to tell you what's at the top of the integral. So that's sort of the other next part of using LaTeX. These little curly braces are used for special arguments that go with the symbols to tell you sort of where special parts of the symbol are going to be going. There's another example of that is when you're dealing with fractions. So fractions, just like integrals, you have a slash and then a special string of characters, in this case /frac. But of course, fractions have two parts, right? They have the top part and they have the bottom part. And so LaTeX has to have some way of knowing which part goes where. And it's about as simple as you could hope for. The top part goes in the first collection of curly braces, and the bottom part goes under the second pair of curly braces. Okay, so that's integrals and fractions and so on and so forth. Now, At this point, you might be thinking, my goodness, there's a whole lot that I have to learn at this point. And there is. There are a lot of special symbols that you're going to need to get used to if you're going to be typing LaTeX. I think the most comforting thing that I can say is it's very difficult to learn them by listening to a video because, of course, I'm talking through a bunch of symbols and you're not actually doing it yourself. However, within a week or two, you'll find that the dozen or 2 dozen symbols that you use most often are going to become sort of like muscle memory. And so most of them are not are sort of reasonable symbols to remember, right? Int for integral, frac for fraction. Very many of them are short forms for sort of the standard notation, and you'll get used to using them fairly often. One thing I wouldn't suggest is trying to memorize a table. Instead, what you should do is open up a document like this one, which has a lot of the symbols that are commonly used, and every time you need to use one of the symbols, you can just copy paste wherever it shows up. Okay, so that's sort of an easy way to do that. One thing that's helpful is you can look into this PDF view and you can hit these little arrows, and they're going to be going back and forth between the code and the PDF. So if you find the symbol that you're interested in, you can use the arrows to find the associated code fairly quickly. So that's most of math mode. The one extra bit of math mode that I think I need to call out for special attention right now is dealing with long strings of equations. So let's see what that looks like. So if I do sort of a calculation, right, I don't just want to be able to say, for example, the integral from 0 to 3 of x squared dx. I want to have this nice thing where I say, well, it's equal to something, and then I have a bunch of lines in a row which are all nicely sort of lined up with each other in a way that's easy to see. So most of doing that is just remembering how to type up integrals and fractions and so on. But there's a little bit of special extra stuff that you need to do in order to make it look nice like this. So the first thing that you do is you need to tell LaTeX, hey, I'm not just writing down sort of one symbol, I'm writing down a sequence of equations. So in the LaTeX template, you can just write /be for begin equation, and /ee for end equation, and that's telling LaTeX everything in between is going to look sort of like this. And then almost everything that you write is exactly the way that it is before. The only thing that you have to tell LaTeX is when a line ends and what parts of the line are lined up with each other. So this double slash thing here, that tells you that I'm done with the line. And this ampersand here, that tells you what needs to be lined up. So you'll notice I don't line up the equal signs when I'm writing in the LaTeX. Instead, I write this little ampersand here, and that tells LaTeX, hey, when you're making the PDF, line up the things next to the ampersand. Okay, great. Again, that's probably a little bit much to learn all at once when watching the video, but if you open up the PDF guide, you can walk through it a little bit more slowly, and you can see I go through all of the details sort of line by line as I go. Okay. So that's it for the LaTeX system. That really is almost everything that you need to know to get started. The only part that's difficult at this point is that there are a lot of special symbols in mathematics, and you're going to need to try to figure out what those symbols are and how to write them down. If you open up the guide, there's a section at the end which has many of the most common symbols in this class. So here are a bunch of symbols, quadratics, superscripts, subscripts, integrals, fractions, and a bunch of special symbols about less than and equal signs and limits and so on. And I say also how to typeset all of those. Okay. So that's sort of enough to get started, and probably that list of symbols is going to get you through, well, 80% or so of the class, but it's certainly not going to get you through all of class. And so I'll sort of highlight 2 other things which are helpful beginner resources. So first of all, there's this LaTeX cheat sheet, which is fairly handy. It's certainly not everything either, but it's a lot of LaTeX and a lot of the most common sort of special things that people want to do to make their documents look nicer. Another one which is really fun is this website called DTechify, and I'll just show you how I use it. It'll have this square here, and you can use your mouse or a tablet to draw some symbol. And then when you're done, it'll guess, hey, what's the symbol that you intended to draw? It'll give you a bunch of guesses, and it will give you the LaTeX code for all of them. So often when you're getting started with LaTeX, you'll have this sitting next to you, and you'll just try to draw the symbol that you're interested in, and what you'll see is that it's pretty good at guessing. So if I want to write down the symbol for the real numbers, it will probably do it, yeah. So it gave me sort of the second option, gave me the right answer, the thing that I was looking for, even though my drawing is, of course, fairly terrible. Okay. So that's enough to get through most of LaTeX. That's obviously not a comprehensive introduction to the subject, and if you'd like to, there are plenty of guides online, and I'd be happy to post more of them on Piazza or send them to the class. But it's not really necessary. We want you to use LaTeX in this class and to get used to typing things up, but we don't need you to be sort of agonizing over the documents. Having a functional understanding of the language is something that you can acquire pretty quickly, and that will be good enough for us. Thanks very much, and next we'll be going on to some